Welcome back to our Snowflake Masterclass. Today we will break down one of the Snowflake's most powerful feature, multi-clustering and scaling policies, so that you go from curious beginner to confident pro by the end of this episode. So let's understand what the multi-clustering is. So a Snowflake virtual warehouse is how your queries run. It's a simple definition that a Snowflake virtual warehouse is how your queries run. But what happens when tons of users run queries at the same time? You guessed it right. Queues can form. User might wait longer for the result. For example, for example, just guess. Just let us assume that this small warehouse can query 100 queries per second, but in because of some peak hour or a time where most of the data analyst or machine learning engineers are working. So for example, there are 1000 queries per second the virtual warehouse is getting. So at this stage, the maximum capacity for this warehouse is 100 queries per second, but we are getting 1000. So in that case, what's going to happen, that the later 90 queries will have to wait longer for the result. So for this solution, the multi-clustering comes in. Multi-clustering lets you assign more than one compute cluster to a single warehouse. For example, there is a warehouse named ABC, which is of small size. So in a situation, it's working with a small warehouse or computation. So at this time, now for example, there are more queries than 100 per second. So what it will Snowflake do, it will assign more clusters to the warehouse. So the queries get distributed across multiple clusters, and what will be result of this? Faster execution. Means more clustering is used for more queries. It's like opening extra checkout counter during a supermarket rush. Less waiting and more results. So there is also thing called auto scaling. So now imagine your workload suddenly spikes. Imagine your workload suddenly spikes, and Snowflake's auto scaling feature automatically detects that there are more queries are in queue, and detects when queues are forming, and spin up additional clusters with no manual effort or no downtime. Means automatically it is done by our Snowflake architecture, and it's known as auto scaling. So auto scaling asks, when should I start up a new cluster to handle more queries? When the system detects enough queued queries or heavy load, it launches extra clusters. Once demand drops, Snowflake automatically scales the cluster back down, and saving your credits or indirectly money. So when it comes to the policies, we are going to do a practical for the same also. So when it comes to the policies, there are two basic policies, and these are economic standard and economy. There are two different policies. So scaling policies in Snowflake determine how aggressively or conservatively your warehouse adds and removes clusters. You get two main options. Standard policy. Standard policy will approach react quickly, stating new clusters as soon as queue build up. Ideal for business critical workloads where speed matters the most. It means when you need the speed, you have to go for some standard, and when you need to save your money or credits, then you have to choose economic policy. So economic policy is actually more cautious about adding clusters only if absolute need is there. If there is absolute need, so it will add those clusters. Means it's the policy which is keeping cost lower, perfect for non-urgent tasks or when saving credit is the priority. Think of a choosing between fastest route and the most fuel efficient route for your queries. Indirectly it's like fastest route or most fuel efficient route. In short, standard policy favors the additional warehouse, starting additional warehouse, whereas economic scaling policy favors conserving more credits rather than starting additional warehouses. So there is the exact difference between these scaling policies. You can go through these things. Means in standard policy, immediate starting of the cluster happens, whereas in economy there is a standard time of 6 minutes. Means if any query is waiting for in queue for more than 6 minutes, then it will start the new clusters. So you could go through this and you could also search on the web, and that's a basic difference between these policies. So here's a cheat sheet for choosing your scaling strategy. Means urgent analytics go standard, routine task or bulk processing go economy. Both policies automatically scale clusters up and down, so you get flexibility, control, saving tailored to your workload. So later in our episodes we are going to setting up multi-clustering or customizing or scaling policy, and we are going to have hands-on demos for the same. Or have question about real world cases, drop them in the comments. I will walk you through step by step. So what's next is that there are some Snowflake certification exams you could go through on the Snowflake website. So there are 3 questions. You have to go through these videos, pause my video, read the question and try to attempt the question. So the first question is, what are the 3 main layers of the Snowflake architecture? So I think that's the easiest most, that the 3 main layers are storage, query processing and cloud services. In Snowflake, where is the data physically stored? So we have gone through in our basic first or second class that the data is being stored on the cloud storage attached or linked with your Snowflake account. So cloud storage services are going to save the physically storing the data. And which layer handles metadata management, security and query optimization? You should know that it's the brain of the Snowflake. So that's cloud services. In storage, the data is being stored, compressed, optimized, and in query processing layer, that data is going to be, means it's like muscles of the system. So in query processing, there will be virtual warehouses which are computing or calculating the or execution of the queries, and in cloud services or brain, administration is going to happen. So metadata management will be here, security and query optimization, role based access will happen, everything happen here. So these are the next 3 questions are from virtual warehouse and compute related architecture. So what is Snowflake virtual warehouse? A data storage unit, an independent compute cluster used for executing queries, a user interface component, a type of cloud storage. It's not a cloud storage, as AWS and GCP are being used as a storage. It's not a interface component, it's not a data storage unit. So the right answer will be B, an independent compute cluster used to execute queries. So what happens when you resize a Snowflake ultra virtual warehouse? So it do not change the storage capacity, as storage is being used in AWS or GCP platform. So it adjusts the number of virtual CPUs and memory available for query processing. It changes the data retention period. It modifies metadata or size. So the right answer will be virtual CPUs, number of virtual CPUs. Similarly, how are Snowflake credits consumed with respect to virtual warehouse size? Here, larger the warehouse, larger the more credit per hour will be consumed. So I think there should be no confusion in these questions. So next question is scaling and multi-clustering. So what does multi-cluster warehousing in Snowflake enable? Actually, we have gone through this question in this video itself. So the first option is data replication across region is not the correct one. Multiple compute clusters serving the same warehouse simultaneously to manage concurrency. That is the right. So here the second option is the right option. Multiple compute clusters saving the warehouse simultaneously to manage concurrency. Data transformation is not the right answer, and virtual machine provisioning is also not the right answer. So the second question is, when does Snowflake's auto scaling feature or add additional clusters? So as we have gone through that, if there are queues of queries, then more clusters will be added. So when query queues build up due to workload surge, then the additional clusters will be added. Similarly, which scaling policy in Snowflake focuses on minimizing credit consumption? It's the economy, and for performance, the standard policy will be applied. So that's all about this video, and there is a bonus scenario question. You have an analytics workload with unpredictable traffic spikes. You want to ensure high query performance, but also you have to control the cost. Which Snowflake strategy should you use? Means unpredictable traffic spikes and you also have to control the cost. So which Snowflake strategy you should use? Using a large warehouse, enable multi-cluster warehouses with economic scaling policy, disable auto scaling, use the smallest warehouse size possible. So what you have to do, just analyze what you have learned till now and try to answer this question. I am leaving it to you only, and you could comment if you not able to solve this question. So thank you for staying till now, and I will request you to please like, subscribe and share my YouTube channel. And in next episode we are going to have a hands-on demo of what we have learned till now. Thank you. Have a good day.